You can share your screen.
Oh, 1 minute, Sneha. I'm connecting in Zoom. You want to go to this hash iterator, right? This class.
You have
right?
to go to the line number 1479, the next node method, which we are looking right now.
This one.
Return next node. Click. Oh yeah, go to that. The next class which you have opened, right? The next class. You have limited files open, so you can click there directly. The next immediate class.
Sorry.
You have hashmap.class. The next class is hashmap$hash, right? Open that file.
Hash, this one. Okay.
Yeah. So now, if you see, this is the new hashmap hash editor. Now, can you see on your left side? Scroll a little up in the same package. So you should see something with concurrent hashmap. Can you scroll down?
We have concurrent modification.
No. Can you go again back to hashmap.class? So now scroll down. Scroll down.
To the left side, right?
Yeah, left side. Okay, you're not getting it. Okay, just go to your fail fast method, the fail fast class which you're using on. Create one more object. Okay, the same object. Just copy the entire map object from line number 11 to 14. Copy the same thing and then paste below. Just rename the reference name to map1. And now instead of new hash map, remove the new hash map. Remove the complete towards right. Now give new space. CON, class is CON. Give control space. You see the first one? Concurrent hash map? Yeah, select that. And save it. Okay, now go to the concurrent hash map. Okay. So now here, can you just give control O? And scroll down. No, scroll. You need to see something again with entry. Values, entry set.
Entry set is the.
No. Go ahead. Go to put method if possible. Go to put method. Select PUT method in this.
In the same drop down, right?
You can just search put. Yeah, the first one. Can you go there? Now go to the put value method. Scroll down. Yeah. Okay, fine. Now what you do is, what is the difference between hash map and concurrent hash map? Both does the same thing. So to just evaluate that, now go to your fail fast versus fail safe method. Yeah. Just copy the content 22 line to the same thing. Like no, just don't place anything. Just replace map with map1. Right now do that. Just replace map with map1.
Okay.
Yeah, and also in line number 26, replace with map1. Wherever you line number 26, wherever you see map, replace with map1. Even in sysout, print map1. Now try to execute this program. So Now, same condition you have here, we should get the same error with concurrent modification exception. Let's see whether we are getting it or not. Did we get now?
No, we are not getting.
We are not getting it. Why so? Because that is the difference between the concurrent modification hash map and the hash map. So the difference is the concurrent is specifically written for multi-threaded programs. Like whenever more than one thread is working, that will be taken care in the concurrent hash map. So now can you open the concurrent hash map class? Go to the top of the class. It's come down and near the class they would have written a description. Yeah, just study this, read this one.
A hash table supporting full concurrency of retrieval and high expected concurrency for updates.
Next
This
one.
class obeys the same functional specification as
Hash table
and includes versions of methods corresponding to each method of hash table.
Okay.
However, even though all operations are
Thread safe. So note the point, all operations are thread safe. That means like you will not get an issue on locking data. So even if many people are working on same map object, doing multiple operations, your data will not be hung or your data will not be corrupted and it will not throw any system exceptions because it is specifically written for a multi-threaded environment. That is the reason you didn't get any errors so far. Yeah, read the next line.
Retrieval operations
Do
entail locking and there is any support for locking the entire table in a way that prevents all access.
You left the not word. So there is not any support for locking the entire table. So you can't lock the table. So what is the hash table they are meaning here is the array of buckets where you go and insert the data with the help of hash code and the mod count, right? That will not be logged. So this is not actually like two persons are not getting logged. So basically you can go to an ATM, do a withdrawal, and the same time in your net banking you can do a credit operation. You can get a credit. Someone can credit you, right? Someone can credit you at the same time, and same time you can go and withdraw. Both can happen same time. There is not giving you any interlock system. Why is it so? Because till now your bank deposit was 0. And by the time someone credited, you got 1,000. By the time you withdrew 500, you got amount. So it was happening parallelly. What if my I went bank first, my amount is 0, and when I do withdrawal, I don't get money. But after you come out of your bank, you see there's 500 in your balance. Someone has credited you. It's a reverse process, right? It should happen immediately. So that type of locking can be avoided through concurrent hash map. So you learn something called hash table. What is the hash table? We'll see that again. Can you scroll in your left side to the top and see the hash table.class? Yeah, open that. So hash map and hash table, are they both same or they both different? They might always be a question. So hash table and the hash map both are same. Okay. So the internal architecture for your hash map and the architecture for your hash table, both are same. But why do we have two separate classes? So before hash map came, so the hash map come into picture only after 1.2. Before that, we were having only hash table. So what is the difference between them? Why do we need hash table and when should we prefer hash table and when should we go for hash map? So both follows the same hash technique, both follow the same key and value pair of data set insertion. And is it okay for me to, instead of creating a map every time, is it okay for me to create a hash table and store all my data? Yes, it is perfectly okay. But why is it so? Why do I need to prefer hash table? Is whenever you're
even
working,
in hash table also we will have that same capacity and those.
Yeah, you have everything. Entire architecture is same. But only thing is that is a legacy version. Hash table is a legacy version because it was initially implemented before hash map has come into picture. Okay, whereas hash map was an advanced version of your hash table. That's it. But What is one more advantage we have in hash table is that can be used in your multi-threaded environment. So whenever you're using more than one thread, you can actually go with hash table, because if you see right now, when you use hash map for just to do two operations together, you ended up with a concurrent modification exception, right? Your system didn't support it. It was throwing you error immediately to perform two actions together. Whereas your concurrent hash map helped you. So the concurrent hash map is again coming from which part? Hash table. So hash table, concurrent hash map, everything are nothing but thread safe platforms where you can perform your action without any discrepancies. So that is one of the reasons. If you want to perform some activity in a thread safe environment, you learn threads sooner. But if you want to do some kind of activity in a thread multi-threaded environment where more than one operation can be performed and more than one activity can be performed together, you need to prefer to go with the thread safe classes and not unthread safe classes. But if you are not running on a multi-threaded environment, like a normal standalone program or normal single coded, then you can go for hash map. Okay, that is first.
So hash table and concurrent hash map also would be like the same, right? Because
both are
support
same.
the
So
multi-thread.
internally, the concurrent hash map is using hash table. See, the words are almost same. The array of bucket, the creation, but everything is same. In legacy, they named it as hash table, and in the later version, they just renamed it as hash map. You can just go into that and see what all methods you have in hash table, what all methods you have in hash map. What is the difference? You can just explore it. Okay.
No, I'm asking about the concurrent hash map. Actually.
Yeah, just a moment. Now, when you go to concurrent hash map class, open that. Scroll down. Just scroll down. It will be a little descriptive. Once your class name comes, just hold. So if you see here, you have class concurrent hash map, which was introduced in which version? 1.5. If you see in line number 262, you can see it was introduced in 1.5. Okay. Now open your hash table and then just go ahead and search like when it was implemented. Scroll down. Line number 120, when you see, it was from 1.0. So the initially when they started designing this structure of key value pair, they went with hash table, because internally what you're doing, you're creating a table mapping all the indexes with the relevant linked list nodes, and then you're pointing and creating a link, and then you're making basically you're maintaining a dictionary data. So that is the reason. If you see here, you can see it extends dictionary, right? Now open hash map and then go there. And then select, go and see the same way when it was started implemented the hash map. Wait. So if you see, the hash map came into 1.2, right? So 1 was hash table, 1.2 was hash map, and 1.5 was concurrent hash map. So on each version, they started collecting the concepts and they built everything together in one or the other classes. So basically, hash table was your legacy one, and hash map came later. And concurrent hash map came later to have the features of both hash table and hash map. Okay. So now, what is the second difference? Now you learned like you can have only one null key in your hash map, right? Now for you, the second assignment is in the same scenario. Try to insert more than one null keys with different values. Not now. Try it as an assignment and come up with your analysis. So create a concurrent hash map. In the put part, give null and give different values, and give different keys and different null values, and keep both key and null as null values, and see what is the size of your map. Is it still taking only one, or is it not taking? So let me know what was your analysis on this. Okay, that is first assignment for you on the concurrent hash map. Now coming back, the concurrent modification exception, how is that being resolved? Now keep a debugger point on line number 25 and 26. and debug the application. And your variables, the logical structure is enabled, right? Logical view.
Which
So
one?
debugger perspective. Yeah, it's enabled. You can debug.
Ah,
Proceed. Okay. So what is the mod count here? Right click on the mod count. No, just a moment. Right click on the mod count. Double click and right click. Okay. Now that is 3. Okay. What is the expected mod count?
3.
3. Okay. Go ahead.
F6, right?
Yeah, just go F6. So go ahead.
Or
Give
give-
F8. Give F8. Now check. Can you just expand your right side, this key? This. You can see the count there itself. Okay, go ahead. Give F8. Mod count is 2 and index is 1. Okay. Go ahead. Okay, go ahead. Go ahead, go ahead. You just give F8.
Yeah, I'm giving F8 only, but still we are getting same value.
Okay, can you just remove the breakpoint here? Anyway, it shouldn't come to hash map because you're still using concurrent hash map, right? Just double click on the breakpoint. Okay, yeah, cool. Now F8. Okay, now I'm not sure why it went to hash map. Okay, because you created object above hash map, right? That is the reason. Okay. Now if you see in your map one, you have 3 elements. It dot get key, right? Okay. Now go to that get key method. Control click and go to it get key. Control click. Go to that method get key.
You
You're
want to
using
go to
concurrent
get
hash
key,
map, right? Go to the concurrent hash map and use the get key method. Anyway, iterator will not give you that. Give control O. Search for get key. First one, you see get key. Okay, but the one you're fetching it from the map.entry, right? So search
No, it
for
is from
other map.
concurrent.
Yeah, in the same one, give control O and search for get key method.
This one, right?
Okay, go there. That is final one, right? It's just returning me key. You're searching in the node. Don't search in the node class. Come out of node class and search it. Yeah, search here again. Get key. So you're using map.entry. So go there. Get key. So here is the place where you're trying to get the relevant keys in. So come down. Okay. Keep a debugger point on the get key method here. Line number 3477.
Here only, right? That's fine.
Yeah, keep a debugger here. Okay. Now give F6. Okay, go ahead. Okay, go ahead. Go ahead. Go ahead. Okay, it didn't work. Okay, cool. I just want to make you to go to the okay, go to concurrent hash map dollar. If you see the right side on the variables, there is a class called concurrent hash map dollar map entry, right?
Yes.
Open that file. expand that 0. Yeah, go to this. Now here, can you give Control O? Hmm. Go to concurrent hash map class, the previous one. Give Control O. Now this is again no. You can close this. This is again no. Okay, close this. Go to the concurrent hash map. You give Control O here. Scroll down. No, don't give get. Just scroll down. Go to that next element, next node or something like that. Just type next on the search. Stable. Okay.
This one, right? Value iterator. Next or key it.
You're using just iterator, right?
Oh, yes.
Entry iterator only you're using, right? Go to the entry iterator. Yeah, go there and click. Go to the next. Yeah, keep a debugger point on line number 3455. Okay. Now give F6. Give F6. Go ahead, F6. Okay. So now, what is the next value you have here? Expand your variables. So you can see the next element, right? Expand the next element. The next element is 3.
3.
Okay. And what is the value in P? No, check over there itself.
Yeah.
In your variables, are you able to see P variable? No. Scroll down. You're able to see anything P?
No, I'm not able to find anything here.
Okay. Just give F6. P dot key. You should get something now K, right? Just give F6 again. Okay, now in the variables, are you able to see K? You have that in the next method.
Yeah, I'm checking here under the key and value.
Okay, that is just an expansion of your array. Now just give again F6. Go for F6. The last written. Now see on the last written. The last written value is having the final data. Okay. So that is having the, it's basically swapping of data. So it happened. And now that finally you got your last written with some input. Okay. Now go to F6 again. Okay. So the next element, whatever you got, is having a relevant value map. Now go again F6. Okay, now go for F8. So now the it.getKey. Now in the right side, in the iterator, in the right side variables, it, expand, you get the value 3.
3.
And because your iterator was happened second time, right? Now you're on the third time. That is the reason you're not getting it. Maybe next time you debug, you'll get to know the actual thing because we executed twice, right? We kept a debugger point in the wrong place earlier. So now execute again F8. So what happened is, if you have observed on your right side variables, you were having every time a new map getting created, right? It was not working on same map. Did you observe that?
I saw like 2 things, right, in the next itself. So that one you're saying key value, like there is
No,
2.
what is happening is, though you're performing in one more operation, back end, it is like not in the same MAP1, whichever you have created. In the back end, it has its own map. Now, can you go to the concurrent hash map next method? The one which we see. Go there. Not here. The other one. So if you see here, every time you're calling the next method. What is happening internally? You have a variable called last return that returns me the object, right? That gives me an object. And if you see line number 3461, it is returning new map entry of key, value, and map. So a new map entry is getting created. Now go to the hash map next node method, which was opened earlier. Can you go into the number of files open and search for that? Go to the hash map, hash iterator. So in the next node, what is happening? We are returning the same element, which is in 1443, the node, whatever you have, we are returning the same element E back in 1451. We are not creating new element. We are using the same element and returning the data on performing multiple operations. Whereas in concurrent hash map, we are returning a new data, new map. So whatever operation you're performing, it is like kind of a copy of data is getting created. So the data set, whatever you're trying to perform multiple operations, it performs and then it creates a new entry. So it is not affecting the existing map. It is creating a new entry. But in case of hash map, it is trying to iterate in the same object and it is ended up with some kind of exceptions. So to avoid such concurrent modification, you can go to concurrent hash map. That is one possible solution. The second possible solution is how to rectify the same issue in our hash map. Why we need hash map is it is very fast in operating. The performance is really faster than your concurrent hash map because concurrent hash map is recreating every time new map and giving us. It is not giving you exception. I accept it. But still, that is not a preferred way to overhead the performance. So that is the reason we always go for fail fast. So what all fail fast functions are? Array list, hash map, and hash set. What is the concurrent hash map that comes into fail safe? The same way for your array list, if you try to do the same thing in your iterator, you will again get concurrent modification exception on array list. So to avoid that, you have something called, can you go to your fail fast versus fail safe class? So I want you to create an array list quickly. Have 2 elements of integer array. That should be fine.
Only one. You want two integer to be. List will have only one value, right?
I want 2 elements in my list.
Oh, okay. Okay.
Import the package of array list. After the array list, after list, give control space and import. Given. If you add in between, you'll get a new value.
Oh, okay.
Yeah. So now go use as iterator for list. Create an iterator for list as you have done for map. Use the same thing. Use create iterator. with integer, create a reference equal to li dot iterator. Equal to li dot iterator. While iterator1 dot has next. Create a loop or a block. Yeah, go in. Now, if itr dot next, itr1 dot next equal to 22, say itr1 dot remove. Okay, now outside this while loop, print li. After while loop, print just li object. So what I'm doing is I'm doing the same thing what I've done in map. So if the value is 22, I'm removing that element. So finally my list should have only 34 as my data. You have to close braces.
Yeah, I'll do.
Give plus, otherwise you're not separating string and object, right? So you have to give concatenation. Okay. Save it and now execute. So again, we are using fail fast operator, array list.
Array.
So, and we are performing the operation
concurrent.
again on top of it. So did we get error this time?
No.
No.
We
Why?
don't get concurrent.
Because you are removing it from which one? In line number 31, if you see, we are removing it from the iterator. Line number 31, you're using iterator object to remove. Whereas in the line number 40, you're using map object to remove, right?
Okay. Yes.
Now, can you just go to line number 40 and see whether we can remove with the help of iterator instead of map? Just after that, give it dot. Do we have remove method?
No, we don't have remove method.
We have remove method. Come down. You have remove method.
So we have remove method.
Yeah. Now save. And now replace your map one with map. Print map. Execute. Did we get error?
No.
So whenever we want to use fail fast operators, try to use the same iterator to remove your element. Don't use the map object to remove it or a list object to remove it. Okay. In that case, we can avoid our concurrent modification exception. But there is also a possibility for us to use the concurrent hash map. But that can be used only in the multi-threaded environment and not in the usual environment. Okay. Now, if you replicate line number 37, go like in the list, instead of itr dot remove, give list dot remove, li dot remove. Li dot remove. In that, give itr1 dot next. Save and then execute. So what happened? We got concurrent. So because you are using the list operator and you're performing again one more object of what? ITR. So the next method is working on mod count, right? You're using the modulus count to compare it. So there is a clash happening between the indexes. So that is the reason you're ended up with a concurrent modification exception. So whenever you're trying to remove an element or perform one more operation within your iterator, like more than one operation for the same list or same map, then you should do it only using the iterator instance and not using the collection
Map.
instance. Okay. So it shouldn't be a map or it shouldn't be a list. It should always be an iterator instance. So in that way, we can avoid our exception. The second point, the same thing, like as you have your concurrent hash map, we can also achieve the same thing through one more class called copy on write array list. Okay, so now I request you to just copy the line number 24, 25, 26 and recreate one more time. And instead of list, replace that with copy on write. Just capital COP and give control space. You should say copy on write array list. You're using array list right now. So use write array list. And just copy the same and paste it on the right side. And replace your list of, oh, you already done it. Cool. Just double click array list and paste it. Yeah. Now, instead of in the line number 33, instead of li, give li1. In your iterator, give li1. And then, yeah, just give li1. Yeah, paste it. And execute. So whenever you're trying to go with multi-threaded environment, you can use your collection object. But if you wanted to avoid the fail safe, you should always use your iterator instance. Okay. So in that case, you'll get the relevant output. And that can be used only in the multi-threaded environment.
Like how we use the concurrent for hash map. This one is for
your array list.
Array.
And the same thing you have for set, copy on write array set, right? You can use that for your set. Now, so you understood how to avoid concurrent modification exception and which one to choose when, right? So I prefer you to always go with fail fast methods like array list and hash map unless you are not in a multi-threaded environment. Okay. Okay. So the problem statement which I gave you to check on null part, you need to check it for your concurrent hash table. So how to create a hash table object and how to insert the data in your hash table would be same as your hash map. So give it try and then experience that. Okay. So what is the fail fast operator? They might come like when to choose fail fast operators or fail fast iterators. So this would be one of an important interview question or also in certifications, fail fast iterators and fail safe iterators. So you need to know what is fail fast and what is fail safe. So the fail fast is the performance is really pretty high, whereas in fail safe, you will not have that level of performance because it's like creating every time one or the other one, right? And the second thing is in your fail fast, you are trying to modify the same object. So that is the reason you ended up with an exception. So in order to avoid that, we can use the iterator instance itself to modify your data and then come ahead. Why are we getting that exception? Because the issue is because of the mod count value, which we saw right in the next node method, where the mod count is getting mismatched every time. And that is the reason you are getting that error. I hope this is clear. So the assignment is create a hash table, add some data, and then do some kind of operations, and then check the null value part on your hash table. Are you able to insert only one null key or you're able to have more than one null key? Check that and tell me. And you will be given with a problem statement on Monday. Using collections, you have to solve it. Okay. So try to brush up all your collections and samples. So now we'll progress on the next level of collection list. Okay. So basic is done. So we'll proceed with how to perform multiple operations with multiple classes. That's all for the day.
Okay.
Thank you. Bye.
Thank you.